To continue on the previous video, the last situation is when we're looking at two functions and how we can evaluate when they're equal and how to add them together. And so when two functions are equal, what it's really asking on a graph is where do they intersect? Where do they intersect? And that's because when they intersect, it means they have the same value at the same time. So that's right here, they intersect. And our coordinate corresponds to the x and y values at that point. So this coordinate is at 2, 5. And so where do they intersect? Well, at 2, 5. B is asking you to add f of 4 and g of 4 together. Well, let's find out what f of 4 is. So f of 4 on the graph would be the function of f when x is 4. So on the graph, I go to 4, and I go up to the up, and I find that it's equal to 7. So f of 4 is equal to 7. And g of 4, well, g of 4, if I go to 4 on the x-axis, and I go up till I hit the g of x line, well, that's equal to 6. So I need to add 7 and 6 together. So 7 plus 6 equals 13. So that means f of 4 plus g of 4 equals 13. I can also do that with this one where I'm not adding, I'm subtracting, except I'm doing it with negative numbers now. So I'm going to go g of 4. So g of negative 2. So I'm going to go negative 2 and go up until I hit the g of x function, which would be right here. And that looks like it hits 3. So g of negative 2 is equal to 3. And f of negative 2 is equal to, well, go over here, f of x is right there, 1. So I'm doing 3 minus 1, which is equal to 2. So g of negative 2 minus f of negative 2 is equal to 2. Then it asks, state the interval where g of x is greater than f of x. The alligator is eating g of x, that means it's greater. Well, that means when g of x is above f of x on the graph. Well, if I look to the right of the intersecting point, g of x is below f of x. So it's all the points before here. So it's everything before this intersecting point. So it has a head start, g of x is above, and then they meet, and then f of x passes. So that's all the way to the left. So all the way this direction to our negative number. So the interval will be from negative infinity until this intersecting point. And we use the x value to describe our intervals, so 2. And I'm not going to use a bracket, I'm using a parenthesis. And the reason why I'm using a parenthesis is because 2 is not part of a solution set, because at 2, they're equal. G of x is not greater at 2. So it is up until 2, but not at 2. Last thing that you may be asked to do is to graph g of x plus f of x. And so the way you would do that is you could pick a few lines, points on the graph, and pick 3 where both functions have nice whole number values at a given point. So what that looks like is I'm going to use right here at negative 2, and we've already found this value, and I'm going to use 4 since we've already actually found those values. And I'm going to draw vertical lines just to help us think through it. And then I'm going to pick one more point, and I'm actually going to pick the intersecting point. Okay, you only need 2 points, so I'm going to pick 3. So I picked negative 2. So at negative 2, I want to see the value of f of x and g of x, and I'm going to add them together. So on the graph, f of x is equal to 1, and g of x is equal to 3. So combined, they're equal to 4. So combined, if I'm adding them together, that point would be right here. At this point, they're both equal to 5, so that means if I added them together, they would both be equal to 10. So here's 9, I want to have to extend the graph, so that would be 10 would be like right up here. And the last one, we already g of f of 4 plus g of 4, oh, copper, he's okay. And it's equal to 13, so I'd actually have to extend this graph up a little bit. So that's 9, that's 10, that's 11, 12, 13, so I'm going to go all the way over here. And so then I can just connect these with a straight line, and that would be my graph of f of x plus g of x.